All right, guys, so this is the second video here in section 4.7, just kind of tying things up. We're going to start talking about a funny sounding word right here called the discriminant. Now, when you hear the word discriminant, we probably think of the word discriminate, which certainly has a negative connotation when we hear it out there in the real world. What the word discriminate really means, if you take out the social context of it, is to tell the difference between two things that are not quite identical, to tell them apart. And so the discriminant then is a part of the quadratic formula that allows us to draw a distinction between different types of quadratic equations. So let's get to it here, guys. The discriminant itself, I use the letter D, obviously, for discriminant, is given by this expression right here, b squared minus 4ac. That should sound familiar, guys, because back in the quadratic formula, here's your discriminant right there. Okay, it is the number that we end up with underneath the radical. So in this first example we did, our discriminant ended up being 289. In the second example, the discriminant right there was 288. It's funny how those were so close. Here, the discriminant was 44. And in the fourth example, the discriminant ended up being 0. So the discriminant is the number without the square root sign, you guys. There is no radical over the top. It's just the b squared minus 4ac. And now, depending on the value of d, we can learn something about the solutions to our quadratic equation. Case number 1, if the discriminant is greater than 0, meaning it's positive, that means we're going to be taking the square root of a positive number. And every positive number has real square roots, everybody, and 2 of them. So if your discriminant is positive, we are going to end up with 2 real, we use the word roots, everybody, but that really means the same thing as 2 real solutions to our equation. All right, so 2 real roots. Now, we haven't discussed the concept of a real number all that much because we haven't discussed the concept of an imaginary number either. And this book that we're using here deals with the concept of real versus imaginary numbers in section 4.9, which comes after this. Excuse me, 4.8. So, just humor me for right now, but we'll do more with that in the next section. The second case is if your discriminant is equal to 0, like in that last example that we did. And when that happened, you guys, because 0 has only one square root, we have only one solution to that equation. So if your discriminant is equal to 0, we have one real root or solution. And it does end up being a real number as well. And the third case that unfortunately we're not going to be able to talk about very much today for the reason I just mentioned, if your discriminant is negative, that might put you in a situation like this. X is equal to, and I'm just making stuff up here, guys, 7 plus or minus the square root of, okay, if your discriminant is, let's say, negative 5, let's run with that, all over 2. We haven't seen an example like this yet, and that's probably good because I don't think you guys know how to handle the square root of negative 5. What it's asking us is what number times itself equals negative 5? Well, if you think about that, how can a number times itself equal a negative? If the number was positive, positive times positive is positive. If that number were negative, negative times negative is positive as well. If the number were 0, 0 times 0 is 0. There is no real number times itself that equals a negative number. So when that happens, guys, when your discriminant is less than 0, which means negative, we have, let's write this down now, 2 imaginary solutions. Now, unfortunately, like I said, we're not going to talk much about imaginary numbers until we get to section 4.8. So for now, let's just have that written down. And then this last little line right here will make some more sense after we come back to it after 4.8. Okay, so how can you use the discriminant? You can use the discriminant to determine the number of real solutions that you have to a quadratic equation. So notice, guys, the directions are not asking us to solve this. They just say use the number of real solutions. And we use that, or excuse me, we get that by using the discriminant. B squared minus 4ac. So here we go. Our b value right there is negative 1. So negative 1 squared, negative 1 times negative 1 is positive 1. Minus 4 times an a value of 7 times a c value of 11. Okay, so D is equal to, and if I were you guys, I would type all of that into my calculator in one step. And in fact, I might do that too, because I think we end up with something ugly here. 1 minus 4 times 7 times 11. Let's go here. Oh, whoa, that was weird. Sorry about that. Okay, 1 minus, we have a 4 times a 7 for our a value, and then times an 11 for our c value, and we end up with, negative 307. Now, the value of that number isn't really all that important, but the sign is. We ended up with a discriminant value that was negative, less than 0, so that means we have two imaginary solutions. Now, I could write that down. This is right, two imaginary solutions, but if I go back and read the problem again, determine the number of real solutions to this equation. Well, guys, if your two solutions are imaginary, what that really tells you then is that we have 0 real solutions. And that is the answer to this question here. Okay? All right, and that's what's going on with this one. Now, I wanted to throw one other thing at you here. Sorry, guys, my spacing here is ugly. This is something that's pretty cool, too. A secondary benefit of the discriminant is this. If your discriminant is a perfect square, that means that your quadratic expression can be factored. Interesting. And if your discriminant is not a perfect square, don't bother trying because it can't be factored. So I just wanted to show you two quick examples here to illustrate that point. Let's look at example 1, 6x squared minus x minus 15. Let's find our discriminant, guys. It's b squared minus 4ac. b is negative 1. Negative 1 times negative 1 is 1. And then minus 4 times an a value of 6 and a c value of negative 15. Okay, and what's going to happen there, guys, is we're going to end up with, now that minus is going to turn into a plus, and let's see, 4 times 15 is 60, 60 times 6 is 360, 1 plus 360 is 361. And the square root of 361, you guys go ahead and type this into your calculator if you don't believe me, is 19. So here, the discriminant, 361, was a perfect square. And if we read again what's written at the top right here, if your discriminant is a perfect square, this quadratic equation could be factored. Let me try that real quick and see how bad it's going to be. I'd probably split the 6 square x squared up into 3x and 2x. The signs are going to be different. I don't know which it is, so I'll try plus and minus. And splitting up the 15, how about a 3 and a 5? Now, real quick, don't even bother putting the 3 here and the 5 here, because if I put the 3 here, this 3 and this 3 would be a GCF that you could pull out in front. But if I look at the original trinomial, there is no GCF there. So there's no way that the 3 and the 3 get paired together. But how about maybe a 5 here and a 3 here? Now my outer product here would be negative 9x. My inner product would be a positive 10x. That makes 1x, which is almost what I wanted. It's just the opposite. So all that tells me is I got my signs backwards, guys. So instead of a plus, there we go. Instead of a plus 5 and a minus 3, I think this is going to be a minus 5, and this one will be a plus 3. And there's a plus 9x, and there's a minus 10x, and that gives you the negative x that you were looking for. So hey, because our discriminant was a perfect square, we can spend the time trying to factor that. But let's take a look at this second example right here and see if we can learn anything from that. 12, big numbers now, 12x squared plus 7x minus 24. So our discriminant then is going to be b, which is 7 squared. That'll be 49 minus 4 times an a value of 12 and a c value of negative 24. Now, guys, those are big numbers. I'm going to use my calculator for that. Okay, so 49, 4, 12, negative 24. I'm not going to remember that. Okay, so where was I here? 49 minus 4 times an a value of, I thought 12. I'm going to double check that, and a c value of negative, something. Where were we? 4, 12, negative 24. Gotcha. There. And then minus 24. Okay, we end up with this big number here of 1201. All right, gotcha. So that is the value of our discriminant. And this test says to find out if the square root of 1201 is a perfect square. So what happens? That's a big number and not one we need to have memorized here. Let's try it, guys. The square, clear that out. Nope, and hit enter. Here we go. The square root of 1201 is irrational, guys. It ends up being an ugly number. So 1201 is not a perfect square. So that means that this expression right here, everybody, cannot be factored. Now, I want you guys to think about how hard that would have been to figure out if you had just tried factoring this thing. 12 can be split up, oh boy, 3 different ways. 3x times 4x, that's 1, 6x times 2x, and then 1x times 12x. The 24 can be split up, I think, 4 different ways. 6 times 4, 8 times 3, 12 times 2, and 24 times 1. That means, if I'm doing my math right, there are 12 different things we would have needed to try to factor this. And the old way of doing things, we would have had to try all 12 and then found out that none of them worked to say that this expression was prime and it cannot be factored. But you can use the discriminant pretty quickly and easily and realize that if we come up with an answer that's not a perfect square, your expression cannot be factored, so don't bother trying to factor. You would then try to solve this one immediately with either completing the square, not a good example in this case right here, a good idea in this case, or rather the quadratic formula. Okay, guys, that's what I really wanted to teach you guys about the discriminant. And the last thing I said I would do, I would not mind at all if you guys turned off the video and didn't pay attention to this, but just in case anybody out there is curious, where does the quadratic formula come from? It comes, everybody, from completing the square, CTS, on this general form here of a quadratic function. Let me show you how we do that. Step number 1 to completing the square, bring your constant to the other side. So that's going to get you ax squared plus bx is equal to, that's a minus c and a minus c, we get a negative c on the right. Then, nobody likes completing the square when you've got that a out in front of this whole thing. So what I'm going to do here, guys, is divide all 3 terms in this equation by a. Those cancel, and we get x squared plus. Now, you can't do anything with b over a, but then I'm going to multiply that by an x right there, and this all equals the opposite of c over a. Okay, kind of ugly, but here we go. Time to complete the square, and this gets weird. We take this coefficient right here, and we cut it in half, guys, and half of b over a, let me write this out, half of means times b over a is going to get us a b over 2a. So we take half of that middle term, and then we square it. b over 2a gets squared. You square the numerator to get b squared. You get the denominator and square that as well. 2a times 2a is 4a squared. And that is what we're going to add on the left side, b squared over 4a squared, but we have to balance that out by adding it on the right side as well. So plus a b squared over 4a squared. Now I know it doesn't look like it, you guys, but this is a perfect square trinomial, which means it factors into a single monomial squared. Let's see if we remember how to do this. You take the square root of your first term, and that's the first term of your binomial here. That's just x. You take the square root of this last term, and that would be b over 2a, and that's the second term of your binomial. And whatever this sign is right here, you bring it right down, and that's going to be a plus. So it's x plus b over 2a quantity squared equals, and now we would try to simplify the right side. And to do that, everybody, we need a common denominator between a and 4a squared. So that common denominator is going to be 4a squared. I'm going to multiply this guy by 4a and the top by the exact same thing. Now that's going to make this denominator 4a squared, and we can put them together. So this numerator is now going to be, let's look right here, negative 4ac plus b squared. Negative 4ac plus b squared all over that common denominator of 4a squared. And I'm wondering at this point if you guys aren't starting to recognize some of the weird terms here that we're coming up with as part of the eventual answer here for the quadratic formula. Okay, so where are we now, guys? It is time to solve this new equation for x by taking the square root of the left and the square root of the right. Now on the left, that's easy. The square and the square root cancel, and we get x plus b over 2a equals. Now this gets a little bit more interesting here. One thing we haven't talked about much, you guys, I'll ask you to trust me on this one, is that the square root of a fraction can be broken down into just the square root of the numerator and the square root of the denominator, and then let's get rid of that radical. Now, there's not much you can do right here, guys, in the numerator. I'm going to make that the square root of, and I'm going to change the order of the two terms under the radical. Instead of negative 4ac plus b squared, I'm going to make that b squared minus 4ac. And wait a minute, anytime we put a square root there, there should be a plus or minus out in front of that. Down in the denominator, this is cool, 4a squared is a perfect square. Its square root is 2a. And now, you guys, we're really one step from being done. The last thing we have to do now is subtract the b over 2a from both sides, and I'm going to put that here, minus b over 2a, and then that plus or minus kind of serves to separate those two. So those terms cancel, and let's see where this gets us. X is equal to, and if you notice, guys, these two fractions now on the left already have a common denominator of 2a. So let's put them together. My numerator starts with this term, the opposite of b, and then plus or minus the square root of, and we had b squared minus 4ac all over that common denominator of 2a. And ladies and gentlemen, after a great deal of work, we have isolated the x in this equation, which means we have solved. We just derived the quadratic formula, everybody, from the general form, standard form, I should say, of a quadratic equation, and using the process of completing the square, we've now solved this thing for x, and that is how the quadratic formula was derived. It wasn't invented, it wasn't guessed, it wasn't something that somebody just hunted around in the dark until they found something that worked. They did a ton of work on that using methods that they understood to be sound, and eventually were able to isolate the x in that formula and come up with the quadratic formula that we all know and love that allows us to solve any quadratic equation with just a wee little amount of work right there. All right, everybody, there we go. That's a wrap on our notes for 4-7. So let's give that homework a try, and good luck, everybody.